We are live for
Yay.
Open Tech Will Save Us number 5. That is number 5. If you've seen the background here, you may notice that I am not in my comfortable home. I'm in my fairly comfortable office. That is because the office has air conditioning. And in the world right now, it is so hot that I cannot be in my own home while talking on video. So I've decided to move. Anyway, we have I'm genuinely, personally, really excited about this lineup. So we have Matthew Petrie, who will be speaking to us from Pint 64. We have Jonathan Berry, who has done many things, but he's known for his making of different things. And he is going to be talking about some really cool IoT stuff. And then finally, we've got we're changing tack, not quite so much tech, and we're going to hear from Nad Christie, who is actually employed by Element, same as myself, and he is going to discuss the rebrand that we enjoyed this year. And actually, I love the results of this rebrand, and I think that it's really important to understand the technical meaning behind all the work that went into that, and to really appreciate why that work was so important and why it was, such a work of love for everybody involved. Anyway, firstly, we have Jonathan Berry. So why don't we say hello, Jonathan, and introduce yourself?
Hello. Let me get my screen share going, and then we'll have some slides. Can you see the slides?
I can, yes. I'm going to mute. Awesome.
Well, hey, everyone. Thanks for having me. This talk will be about WebAssembly and the Internet of Things. And really, so this long journey I went on, getting excited about WebAssembly, why it's a great technology, and actually how I think it will improve a lot of making of things. So the title of the talk is Making It Easier to Make Things with WebAssembly. So a brief bit about me. As we said earlier, my name is Jonathan Berry. I'm a product guy. I'm also a founder. In the Bay Area, I organize the WebAssembly SF Meetup. It's the largest WebAssembly meetup here in the US and maybe in the world, who knows? And like I mentioned, I'm using some of my experience to build my own IoT startup. And if you'd like to talk to me more about WebAssembly, IoT, making gelato, which is another weird hobby of mine, you can reach me on Twitter at BerryBerryKicks or on Mastodon if that's your thing. So as the fulcrum of our conversation, we're going to talk about things. And if you have played around with IoT or hardware, this might be familiar to you. This is an Arduino, a very common platform to take code and interact with the physical world. And a lot of people who experiment with hardware start with this toolkit. And when I talk about IoT and I talk about WebAssembly, the first thing everyone asks me is, can you use WebAssembly on an Arduino? Reasonable question. And really, what we're going to try to answer today is such a thing even possible? And hopefully we'll get there, and a bunch of other things with this brief agenda. We'll start by defining the term Internet of Things, or IoT. Kind of make a use case for why Internet of Things and WebAssembly actually make a ton of sense. And some forward-looking things, where we are today, the state of the art, and what's possible in the future, or maybe what we could build together if you're interested in this space. So let's get going and define the phrase IoT, the Internet of Things. Okay. Now, we know what the internet is. We're using it right now. And we know about things like your smartphones, your servers, your laptops. But when we talk about Internet of Things, we don't mean these things. We actually mean quite a different set of things. And it's a whole gamut of things that are not cell phones, laptops, and servers. We sometimes call them embedded systems, but they take the form of small Bluetooth devices like headphones or digital assistants and door locks and washing machines and medical equipment. And they're very different than their bigger counterparts. We oftentimes call these types of things constrained devices. And the reason why I call them constrained devices is because they have a lot less resources typically than your counterparts. They're constrained on compute power. Maybe they'll have 64 megahertz of processor on a single core. On RAM, you might have 120 kilobytes available for the entire system. That's the operating system, your applications, the networking stack. It's not a whole lot of space. And maybe you'll have half a megabyte of flash Maybe it will be running on a single AA battery. Even your networking connection might be constrained. And this is due to a bunch of different reasons, usually cost savings, sometimes constraints of the overall physical requirements or whatnot. But it's a very different type of system you have to build for. And as such, these constrained devices have very optimized software. The reason is you have to be deliberate of how you use those resources and not be wasteful. You might be using a C++ code because it'll be a little bit more efficient than something like a Java. Or you might even be running assembly because you have to squeeze every last bit of compute. And fortunately, there's a lot of people who develop software for these types of embedded systems, for these constrained systems. And there's a cornucopia of software that encapsulates that. Sometimes we call those embedded operating systems. Sometimes we call them real-time operating systems, or RTOSs. And they're bound to help encapsulate best practices of programming these systems. And I'd be remiss if I didn't go back to the internet part, because I said, yeah, we all know about the internet, but even connectivity for these constrained devices is unique. There's a whole bunch of forms of connectivity, not just the Wi-Fi or Ethernet you might be using right now, but wireless networks, industrial networks, and even things that are not based off of internet protocols. And usually the connectivity that ultimately provides the internet connection is highly specialized. It's optimized for, let's say, an embedded system, and it's often even included into the physical device itself. So those networking stacks are not the same as a Node.js server. So you couldn't just take vanilla Node code and run it on top of your typical constrained device. And so that's my definition of IoT and embedded systems and constrained systems. We'll use that as the basis. There's other definitions, but you'll hear me refer back to sort of these type of corner cases. All right, so that went pretty fast. And now we'll get to the sort of the meat of the topic, which is why would you even want to combine WebAssembly and Internet of Things? And I'm going to assume that a lot of folks who are watching now are familiar with WebAssembly. If not, there's a bunch of great resources on the internet. WebAssembly.org is a great place to start. But when it comes to WebAssembly, I first heard about it in 2017. Pretty early on in its journey there. And even back then, the creators of WebAssembly, both from the engineers who are designing it and to the companies who are trying to use it, talked about Internet of Things as an early use case. This is one of the diagrams from Lynn Clark, a fantastic speaker and engineer around WebAssembly. If you don't know about Lynn Clark's cartoons, she's at Mozilla doing code cartoons. So a great way to understand very complicated topics with very easy to follow cartoons. Anyway, it's not just the cartoons that thought about Internet of Things as a core part of a use case. Even the spec itself. This is WebAssembly.org. That's the website I mentioned. When they released the initial version, they talked about web and non-web from day one, and they postulated that the capabilities that WebAssembly brings to the web ecosystem would actually be really useful outside the web. And in 2017, it was pretty blurry, just a general concept, but even the spec aligned with that, with the core as well as a JavaScript runtime. But it was pretty nascent. And about me, in 2017, I was working for a company called Particle. And Particle is an IoT platform, and they make the full stack to build your connected product. Hardware, connectivity, developer tools. And I worked on the hardware platform. I was the product manager for things like the modules we made and sold to developers, our embedded operating system, the RTOS I mentioned. We had our own version of that, and all the developer tools that helped developers program our devices. And I spent a lot of time working with our community and trying to improve the developer experience. This was one of the key tenets that I focused on. And well, we got bit by Atwood's law. If you're not familiar with Jeff Atwood, famous engineer in his own right, he coined his own law that states something to the effect of any application that can be written in JavaScript will eventually be written in JavaScript. And that meant for us, can I run JavaScript on Particle? Now you remember in the beginning of the talk, I mentioned that these are very constrained devices, very limited RAM, and what we know about languages like JavaScript, they're not optimized for being very efficient in their own right. But there was a lot of people who also wanted to run JavaScript on embedded systems, not just Particle users. And there was actually a plethora of implementations that take languages like JavaScript and strip out the unnecessary bits, re-implement them to be super efficient, and run on these tiny devices. And they actually kind of work. And not only that, there's multiple implementations. There's multiple JavaScript runtimes. There's also Rust and Python and Lua. And from a company perspective, we said, hey, this could be interesting. How do we go about doing this? Do we do a shim? Do we figure out, maybe pick one language and one runtime and call that first-class support? Then we had a different idea. And this is something that really started to get my wheels turning about WebAssembly. Well, what if WebAssembly was the runtime that we targeted as a company? So we made a specific implementation that allowed WebAssembly to run on our embedded devices and allowed developers to use any language. So effectively, WebAssembly would be the intermediary. We do a one-time integration into this WebAssembly and runtime, and then any language runtime developer or even future language creators could target a particle through this effort. And the main reason this was so interesting was because if we wanted to target all these different runtimes and all these different languages, it'd be a ton of overhead, sprawling technical debt. And here we could do a one-time, high-performant, really secure integration with our single runtime and get the fruits of future languages. And that is what brought me into WebAssembly and how I got started doing the Meetup. But unfortunately, in 2017, there was no embedded runtime that could fit on a tiny embedded device. This is actually another great website you can find on GitHub. Awesome WASM runtimes. It's a running list of all known WebAssembly runtimes, both in the browser, ones extracted from the browser, as well as can target other environments, which is a little teaser to where we're going next. So now bring us to the present. It's mid-2020, and some ideas of where we can go even beyond that. So to break that down, let me talk about runtimes, which I've said that word, I don't know, 5 times already. Talk a little bit more. The standards itself, the standard WebAssembly standards, and some additional ideas of things that I've been looking at, experimenting with the community, and opportunities to do things like IoT protocols and tools. So we'll dive deeper. Let's start with runtimes. It was about mid-2019, and the group within Intel released an experimental runtime. It was the very first runtime optimized for embedded systems. They called it the WASM micro runtime, or WAMR for short. And even when they first released it, it was working. The device on my left, at least, with the screen is a tiny microcontroller, one of those embedded systems, with a screen, a touchscreen interaction, and a GUI, all running on a microcontroller device. And you can see on the right, this is the actual architecture of the system. It's quite complicated. And by that, I mean feature-rich. It's the ability to load different versions of a module. You can have multiple applications, WASM modules running at the same time, a system for software updates. Needless to say, pretty impressive project, even in its incarnation in mid-2019. I should also note that since giving this talk, a new alliance is formed called the Bytecode Alliance, and it's specifically focusing on projects and companies trying to build use cases and software around bringing WebAssembly outside the browser, including IoT devices, but servers and other applications. And so this project was donated to the Bytecode Alliance. And if you want to learn more about the Bytecode Alliance, you can go to the website. And for my early 2017 idea of having WebAssembly running on an embedded system, this was kind of it. We actually had a running code, WebAssembly code on an embedded device. So it was that early sort of kernel of the idea that we had back when I was at Particle. Now, I mentioned that I'm an IoT nerd and a big WebAssembly nerd. I'm also an obscure operating system nerd, and I'll explain why that connection is relevant here for the first demo we're going to see. If you're familiar with let's say modern operating system, multi-user operating systems like Linux, and they have a whole bunch of software capabilities, and that same software is running on the cloud. And is also running on edge devices, like I think we're going to hear from the Pi64 folks later. But there's also this movement in software and academia around what are called unikernels. So there's specialized operating systems that strip out all of the unnecessary functionality, like floppy drivers and security stacks you don't need to make a very minimal operating system. They're called unikernels generally, or library OSs, and they're actually awesome, interesting. They live mostly in academia because they're pretty complicated. The tool chain's not quite there, but they have a lot of benefits of size, performance, security, a little smaller surface area of attack. And if you kind of squint, there's specialized software running on reduced memory and footprint. So they're actually kind of like the RTOS, I mentioned, but targeting different types of hardware. And so I've always been fascinated by them, having been in kind of both worlds for a long time. And I mentioned it's largely in academia, but there's a project under the Linux Foundation, a sub-project under the Zen project called Unicraft. And this is their term, but basically it's the toolchain and library ecosystem to make unikernels accessible to everyone. And the toolchain is really important because that's what's been missing in the space for a very long time. And they target everything from cloud, so being able to have smaller containers in the cloud ecosystem, to even bare metal. And this is the long drawn out connection between WebAssembly, IoT, and Unicraft. Bare metal is like an embedded system, right? You don't have a traditional operating system. So I've been friends with the NEC Lab folks who are the main developers of Unicraft, and I worked with them to put this demo on. Well, they did all the work, and I just got to present it to you all right now. But this demo, I'm going to set it up. I have the hardware here, but it's easier to watch a video. What you're seeing is there's actually a Raspberry Pi. A very typical low-cost single-board computer. Nothing special about it, and it's got the standard off-the-shelf Raspberry Pi touch display. And I'm going to play the demo, and then I'll explain the details afterwards. But the TLDR is Raspberry Pi booting up Unicraft, booting up WAMR, the WebAssembly runtime we talked about earlier, and showing a full interaction with this GUI. So let's watch it first. If I can get my mouse to behave. And so it's in the off state. He powers it on. The screen is turning on now, and the UI is fully loaded, and we're starting to count up. Okay, let me pause right there. So the details are pretty interesting here. The boot time is like 10 milliseconds, plus what says 2.87 for the GPU boot. Super fast. So if you optimize the heck out of Linux for the Raspberry Pi using something like Yocto or Buildroot, you're going to get at best 5 seconds for the entire system. The second thing is the amount of memory it's using. So it's only using half a megabyte of RAM, storage, and then 100 kilobytes of RAM. And you saw the moment the UI was turned on, the clicking started. So why is this super interesting? Well, now if you took your same application and let's say you're building a cloud instance, booting up in in tens of milliseconds is amazing. It saves you on compute time. Things like serverless functions become a lot more accessible. But if you're building an IoT system, let's say it's a mission critical component within a car or a robotic controller, if a system fails, one of the key principles of an embedded system is to have fast reboot because of safety, right? You want that safety system to kick in. And to build this kind of application with the UI that boots up this quickly is really complicated. And this is off the shelf, easy hello world for Unicraft. There's a little more details in the next slide, if I can continue forward. Just to show off the stack, it's WAMR, which is one of the applications supported by Unicraft. It's a Raspberry Pi default base image for the bootloader and things like that, and a graphics stack, an internet stack, all within a half a meg on the file system. Now, I'd be remiss if I didn't explain that 3 seconds. Raspberry Pis are weird devices. I look forward to learning more about the Pi 64 because they actually boot their entire application into the GPU first, and then from the GPU to the CPU. Most embedded Linux-based IoT devices don't have that quirk. So actually, if you're building a Linux controller on top of Linux, typically Linux hardware, you can get WAMR plus Unicraft booting in literally tens of milliseconds, which is amazing. So if that wasn't enough to excite the WebAssembly runtime enthusiasts, late in 2019, so October or December timeframe, another embedded runtime came onto the scene, and that one's called WASM 3. It's by an engineer who's at an IoT startup. His name is Vladimir, and it is a different architecture altogether, and it's the entire runtime. So you can flash this on a device, and it boots everything up soup to nuts. It's optimized for predictive performance, which is a good thing. And the goal is to really target IoT devices. And one of those devices is an ESP32. If you're familiar with Arduinos, actually, this is one right here. I don't know if this is going to zoom in well. It's kind of like a Wi-Fi Arduino. And so you can program in a similar way, but it's an embedded system with an integrated Wi-Fi stack and programmable memory. And so with a second embedded runtime, I partnered with another friend of mine, Alvaro, to build a demo. And it's using WASM 3 on an ESP32. And let's go to that video. And so we'll start this up. I'll do a little voiceover. But in the corner, you'll see the ESP32. When he boots it up, it's probably too small from the screen, but there's a little Rust and a crustacean logo, because this device is now running Rust on WebAssembly on the ESP32. And what he's doing now is actually using one of the APIs he developed on the device to post that device and now update it. So it's running TinyGo. So the same application written in Go, which is TinyGo is a form of Go runtime on that ESP32 device. This is a tour de force and demo, by the way. He's going to do another post in a minute, and we'll see the ability to swap into a third programming language after reboot. Yeah, it's running assembly script. Assembly script is a dialect of TypeScript / JavaScript. So running 3 different programming languages completely on the same device, having the same capabilities. And that's what gets me so excited about the opportunity to program these embedded devices in different ways. But one last thing, because WebAssembly runs also in the browser, those set of applications can also be running in the UI. So you can imagine things like development and debugging and testing being simplified through combining physical devices and web devices. I mean, I can't believe how far we've come from 2017, where WebAssembly is really running on IoT devices. So I get super stoked, because remember we said earlier, can WebAssembly run an Arduino? Is that possible? And as you just saw, yes, it is. So that's awesome. And by the way, all the stuff is on GitHub, both the demos and projects like Whammer and WASM 3, and we'll have links at the very end. And now the sort of present and future. When it comes to WebAssembly itself, there's a lot of work being done to extend the capabilities that are needed to run outside the browser. So just having a runtime alone is not enough. You need to be able to interact with physical things like file systems and networking stack. And so that's a subgroup called WASI, or the WebAssembly System Interface. You go to wasi.dev, you can see all about it. And they're developing a core set of primitives that allows a WebAssembly application to interact with the host environment in actually quite secure and novel ways. It's a capabilities-based permission model. It borrows some of the concepts of the sandbox of the web, but how do you make that run on Linux? How do you make that run on bare metal? And there's a lot of interest across different disciplines. IoT and networking is one area that I'm most interested. The blockchain community is using WASI to interact with different blockchain infrastructure and so on. And so once we get some of that, we get some new capabilities unlocked. But the other areas that I think are unique and interesting for WebAssembly and IoT is around IoT protocols. So you may be familiar with different protocols for communication and ecosystems. And there's a lot. There's actually a very small snapshot of all the IoT protocols that exist. And there's many reasons why there's so many of them, but there are for good reasons. The challenge with a lot of development around these protocols is they're usually implemented in C by the spec writers, by the academics, by the companies who support them for reasons of portability, which makes tons of sense, but it actually makes it less portable into other ecosystems. So for example, if you wanted to use Mosquito, which is the Eclipse Foundation's MQTT server, it's written in C. But if you want to write a Go application that interacts with it, now it becomes pretty crafty. It's not an idiomatic implementation. It has issues with cross-compiling. And same thing with CoApp, which is another protocol, and libcoapp, which is the library. So one opportunity is to take these well-tested, secure, performant C implementations, port them to WebAssembly, which is actually quite easy these days, and then expose once and for all a single implementation to all the different languages and frameworks that you may choose to use in the future. I think that would open up those protocols to more developers in that way. The other area, which is a whole talk in itself, and I don't have time, I'm running out as it is around tooling. So in embedded systems, we have tools just like you have for mobile developers or web developers, but they're pretty crafty. They're pretty dated, especially if you're coming from that world. But we need to be able to program a device. We need to be able to debug a device. We need to run devices physically on the device or in simulation. And there's opportunities for WebAssembly and sort of in the tooling space. As an example, the way you program a device like this, you might be using a standard USB protocol called DFU, or Device Firmware Update. DFU util is the gold standard for that. It's written in C++. But it means you can't build, like Zig CLI tools with DFU util without doing crazy wrapping and having to deal with portability. So wouldn't it be great if we could build tools for programming, debugging, and testing using WebAssembly as sort of the substrate around all that. Just an example of what I mean by build better tools. This is a demo. It's actually implementing DFU-util, but in pure JavaScript. So it's a subset of the spec, but it's combining WebUSB and DFU-util in a hand-coded way. And there's some WebAssembly version of this somewhere to actually program a device, a physical device, that may not have internet connection because it's broken or misconfigured, all through the web. So now you can do for testing, for code labs, for hackathons, for education, or just in the field if you don't have all the right gear. This is amazing. If you're about to debug a physical device deployed, you'll appreciate tools like this. And that's really it. There's a ton of examples we can go through, and I'd love to collaborate with everyone. But first, I want to thank people who helped make this slide possible. First, the Intel team and the Bytecode Alliance, the folks at Unicraft, Philippe, Simon, and Sharon. Definitely check out Unicraft. It's doing amazing things even right now. Vladimir, who built and maintains WASM 3, and Alvaro, who built that tour de force demo of all the different languages running on ESP32. Quick links. Check out WAMR, or the WASM Macro Runtime, Unicraft, WASM 3, and our little meetup, WASM SF, if you want to go check out the meetup page, and all of our previous talks, some of them about IoT, are on our YouTube channel. And with that, that's it for me.
Wow, that really was a rapid tour de force. Thank you, Jonathan. I appreciated that. Yeah, I have a bunch of questions here, but there's something that I want to say up front, which is, how should one really get started with this? Because it just feels to me like there's so much going on, and there are so many frameworks, so many devices. I got hold of an ESP8266.
Yep.
Yeah, but just because I was doing something with Matrix and MQTT, and it seemed like an obvious place to start, and we used MicroPython, which was, again, it seemed like an obvious place to start. But maybe you've got more context on where one should really go to get involved.
Yeah, and you're totally right. This is a massive amount of complexity, and depending what your needs are, your interests are, you live at different levels of abstractions. Yeah. I think it really comes down to where you're coming from. There are really welcoming communities for beginners. So maybe you're a senior engineer, but you've never touched C++ code in your life, or maybe you're an educator, maybe you're a student. One of the companies I think that's doing the best job at creating community and educating people is Adafruit, adafruit.com. They make hardware, some of the hardware you saw on my desk, but also have a great set of tutorials for the hardware they make, and also for the software they write that other people use, and a Discord community with thousands of people sharing information. So in general, that's the first place I would say to get started. And then from there, you have some launch points of which hardware to buy if you know little, which hardware you buy if you know a lot. And then there's the ocean of stuff you can go and learn tons around.
Yeah. All right, so big shout out to Adafruit. Cool. So I'm going to just dive into some more questions.
Yeah.
So somebody's asking, what is the advantage? What's the biggest advantage of executing on a WASM runtime rather than using the native assembly for that device?
Part of it's just the tool you can reach for. The fact that you can run Python on that device means that you can build on your knowledge of Python if you're a Python developer. Or the ability to hire people to help and contribute who may not know how to write low-level assembly. The other area which we didn't get too much into, which is the tooling. Tooling for programming, debugging, testing embedded systems are honestly decades behind any other software ecosystem. And they're just great tooling, but maybe you'll pay $5,000 for a compiler and $1,000 per seat for a debugger. But the beauty of WebAssembly is because it's built around the web ecosystem. There's a bunch of folks who are bringing in tooling, state of the art for things like Clang as an open source compiler and GDB, and you kind of get some of that for free by WebAssembly being targeted for the web as well. And the gap between building an IoT debugger versus just an off-the-shelf debugger is smaller. And so WASM 3 is working on a debugging toolchain specifically for WASM 3. And you're seeing it already that because they can sort of draft on the web, you get a lot of those benefits and build upon it. The other thing, it's not quite there yet, but I mentioned WASI, which is the extensions to WebAssembly that allows you to securely add capabilities. So it's a capability-based system that when you write pure assembly, you got ring 0 for everything, right? That's just the design of these systems. But WebAssembly can add a little bit of a buffer because of the permission model of WebAssembly. So if you're installing third-party code into your IoT device, something you really can't do today in something like an ESP32, WebAssembly can add that layer of isolation and protection.
All right, so it brings you up a level of abstraction and all the benefits that go along with that, I guess.
Yeah.
So relatedly, what's the best approach to getting started with it if you have an Arduino? Is there a way to do that? Because a lot of the time you're talking about devices that have, it's an Arduino Plus essentially.
Yeah. If you look at the WASM 3 runtime, they kind of list out which hardware. At a certain point, that abstraction you have to pay for with WebAssembly.
Right.
So it's not going to replace today all the medical devices in hospitals because you really got to make sure you get the most out of those devices, or consumer IoT devices. Like I don't have any Bluetooth light bulbs in here, but you really don't have those resources. So really, you want an Arduino Plus. Honestly, you should probably get as much to play with as possible, because as you start to add more languages, they might use more memory and whatnot. But WASM 3 is probably the best place to get started if you just want to get your hands dirty. Alternatively, I talked about really constrained devices, but if you have a Pine 64 or Raspberry Pi, you can totally start doing some stuff with WebAssembly with a less constrained environment as well.
All right, cool. Yeah, I mean, so that's what we ended up doing with this. Somebody made I'm going to shout out to Matrix, but the MQTT to Matrix bridge, and we just ended up running Mosquito on a Raspberry Pi and then doing all the MQTT work on there. Cool. Jonathan, thank you very much. What are you working on at the moment? Something in this space, right?
Yeah, and in the space and related. So I'm working on an IoT platform for hardware developers. So if you're a company building electronics and you need all the cloud parts or just some of the cloud parts, we make that possible. And there's some WebAssembly in there too. So.
All right. You seem just so passionate about this topic, so I had to ask that question.
Yeah, thank you.
All right. Thank you very, very much. So next victim is Matthew Petrie. And you're kind of from an IoT space, certainly hardware and some related stuff, right? Why don't you introduce yourself and talk about your, we all want to hear about your employer, which is Pine 64.
All right, so I'll go ahead and start getting the screen sharing going, because it seems like there's been a few issues with that, so I want to make sure I get that working from the start.
There have been no issues. No issues.
See, select screen.
Open tech works great.
All right.
Yay!
So introducing myself, my name is Matthew Petrie, here on the behalf of Pine 64. So on this slide, I have kind of put specifically about Synapse on a single board computer cluster, because I think that's probably the main reason I was asked to come here in the first place, but we'll be talking about a few other things. Oh, wrong keyboard, oops. So 3 things in particular. First thing I want to cover, the 2 sides of Pine 64, kind of going over how it works as an organization, because it's probably not what most people expect, kind of unusual. Then going over our Rock Pro 64, that's one of the single board computers that Pine 64 sells. The cluster of 24 of those we currently have running most of our online infrastructure. And then probably the start of the show, my minor spoilers attempts to run Synapse on it. So going on to that first thing, the 2 sides of Pine 64, or my alternative title of how to make free open source software friendly devices. So starting off, Pine 64, what is it? Well, if you ask Wikipedia, it is an organization which designs, manufactures, and sells single-board computers, notebook computers, and smartphones, which is not really wrong, I guess. Like, in the way you'd expect Wikipedia to do it, that's probably about right, but there's a lot more under the surface there. But one thing it has right is that Pine 64 does make hardware, at least one side of it does, and the actual premise is to make free open source software friendly hardware, mostly on ARM platforms at the lowest possible cost, low barrier entry, make it available to everyone, including devices like the Pine A64 board. That was the first thing the Pine 64 did. There's also others like the Rock 64 and Rock Pro 64, which I already mentioned. The Pinebook Pro, the $200 pretty user-friendly laptop that seems to be pretty dailyable for many people. I know several people who have been using them as their main daily driver computer. And what we seem to be getting a lot of media about recently, which is the Pine Phone, the $149 phone that runs mainline Linux is our main draw there. And it seems like that's a market a lot of people have been looking to come back to after like Nokia N series devices kind of died out. So with the organization, like I said, right off the bat, the main unusual thing is that there are actually 0 employees of Pine 64. Everyone within this organization is either a contractor, which is mostly like the hardware designers and all that, or a volunteer, which at least at this moment is the category I'm in. I don't actually really get paid for this, at least not traditionally. So with that split between contractor and volunteer, you kind of end up with 2 distinct entities within the Pine 64 umbrella, which is the business side of things, which is Pine Store Limited, who handle the manufacturing, logistics, sales, and official support. So like I said, pretty much just handling manufacturing and supporting the hardware. And then the community, which here I am just calling Pine 64 itself, which handles the main website, forum, wiki, chat rooms, social media, and I should have put it here, software. Because hardware is nice and all, but if you don't have software to run on that hardware, your hardware is not worth very much. In fact, it's objectively pretty much useless if you can't run anything on it. And most people in the Matrix community and anyone else who's watching in on this, all of them can probably agree that hardware businesses and open source software tend not to go together very well. There are exceptions to that, but in general, there tend to be several issues because when you have the hardware business making the firmware for their own devices, let's say Android smartphones, for example, you kind of end up with firmware that is full of proprietary blobs, just general software that you cannot make heads or tails of without access to a whole lot of documentation that is locked behind a non-disclosure agreement or any other sort of legal rigmarole. Such as this document right here, which is actually one of the, well, not data sheet, you can see right there, technical reference manual for one of the chips that is actually used on the Rock 64 SBC, with the big confidential banner over it, obviously. So with that in mind, we kind of have separation of responsibilities between the 2 aspects with a rather simple solution. The business side of things makes the hardware and the community does the software. What I just said right there, business, hardware, community, software. And both sides pretty much run independently, but work together for pretty much the 2 sides of the same coin to make the complete product. And there's quite a few benefits to doing this other than having software that isn't locked down behind NDAs and whatever else. Like community software, it tends to be very diverse because people pretty much make what they want. For example, with the Pine Phone, which I already mentioned, there are firmware images for all sorts of Linux distributions, and I think some that even aren't Linux, but within the Linux camp, there's Postmarket OS, UB ports, previously Ubuntu Touch, Mobian, which is a mobile-focused Debian version of Debian that actually pretty much got created because of the Pine Phone. On top of that, also being able to run pretty much whatever desktop environment you want on it, like Fosh made for the Librem 5 also works on other devices. Lomiri or Unity 8 by its older name, or KDE Plasma Mobile. And obviously, it's a Linux device. If you want to run a full version of LXQT or KDE Plasma or what have you, you can. There may be some usability issues on a 6-inch screen, but if that's what you want to do, go nuts. You can do it. community software is also up-to-date software, because whenever you have most embedded platforms, like when I say many embedded platforms, I mean the ones that aren't focused at open source, they tend to, not have open source software. They have all those blobs, or the whole thing's proprietary. And when you have all these blobs, they tend to never get up to date. Like with many of these hardware platforms, they end up relying on BSPs, or board support packages, which are built around a very specific version of the Linux kernel with all of the blobs you need for sound, graphics, everything else. So to some extent, you can try to keep that kernel up to date as long as that version of the kernel gets patches. But once it's out of, if it's not LTS, you're pretty much going to be out of luck pretty quickly. So it ends up obsolete, and you're missing out on performance features and, probably most importantly, security upgrades that you find with newer versions. So kind of emphasis here for what I said a minute ago. Businesses update their software whenever it benefits them, benefits their revenue. Enthusiast communities, as the one that we're lucky enough to have around Pine 64, they update this stuff just because they're enthusiasts and they want to say their hardware is running the latest and greatest software. But this isn't just a one-way street. With how I've said this so far, it may kind of sound like the business side of Pine 64 is taking advantage of the generous community around us, but that's not just the case, because the flip side of this is that the community, especially those developers, get to shape the future of Pine 64 hardware, deciding what sort of directions are taken. Like one particular example I remember a few years back was trying to determine if the community would rather have a spring-loaded or friction-fit card slot for micro SD cards, but also can get much more broad, such as the entire development of the Pine phone, starting in 2018 with this white brick here called Project Anakin, which was pretty much just a bunch of off-the-shelf Pine 64 stuff, a SO Pine board, I believe it's called the Playbox enclosure, a screen, and also pretty much off-the-shelf USB cellular modem. So basically, this is all just put together quickly and handed out to developers as quickly as possible so that they could start developing for it and start giving the business side of things feedback on what sort of direction the hardware should go. So with that in mind, we made it to the second phase of this development with the Don't Be Evil kit, where it's a bit more smartphone shaped, using some of the feedback gotten from the developers for something that can kind of actually fit in your pocket. There are, in fact, pictures floating around of someone fitting one of these kits in their pocket, though it doesn't exactly look comfortable. So basically, refinement on both the hardware and software side of things, leading up to the actual production-ready Pine phones, starting in the latter half of last year with the dev kit versions of the final Pine phone, then to the Braveheart ones, which are the first that were put on sale for people to buy, then wrapping up with the mainboard 1.2 versions of the Pine phone, and more recently 1.2a, fixing all the bugs known with USB, touch issues, and so on, to finally make it a ready for daily use device, at least in terms of hardware. And to show a little bit of practicing what I preach here about how open hardware is amazing and open software is amazing, with you today at this Matrix Open Tech Will Save Us event, I'm presenting from a Pinebook Pro running fully community developed software, in this case, Manjaro ARM, with a fully open source with no blobs build of the Linux kernel 5.8, which is, I believe, only just officially released about a week ago. So just show that. So moving on from just talking about the organization, talking about one of the things that people have been asking us about quite a bit, which is the cluster of several of these Rock Pro 64 boards that we have started hosting most of our online infrastructure on. In a case of, admittedly, kind of the unpleasant term of dog fooding. But again, looking at everyone's favorite source of information, Wikipedia, practice of an organization using its own product. We have plenty of these SBCs. Why don't we run the whole system on it? So we announced this whole plan probably like a year ago, and since then we've had a lot of people asking, like you can kind of see in this collage of Twitter and Mastodon posts of people really wanting this information, because from the start we pretty much promised a blog write-up on this, which still has not happened because we've been kind of waiting to do that until we have this whole cluster set up with everything we want to run on it being run on it, as well as a few issues I may mention. We are still going to do that blog post. This is not a substitute for it. However, this is the first time that any of us have actually gone in depth talking about this cluster in a public environment. So talking about this hardware, it is 24 of the Rock Pro 64 SBCs, each of them with 4 gigabytes of RAM, all the storage being within 1 terabyte Samsung 970 EVO SSDs, mounted in a custom 2U rack mount case with gigabit Ethernet connected to each of those to a backbone switch, and I believe a actual gigabit connection to the internet, with a black back plane to be able to individually reboot each of these nodes, though that's not implemented yet. That's one of the things we want to get to later. And it's co-located at a data center with BBXNet in Slovakia. Thank you very, very much to them. We had hard enough time figuring out where to put this thing. As for the software, which is what hasn't really been mentioned in public, everything I mentioned a second ago has been available publicly if you knew where to look, like blog posts. But as for the software, that's kind of where people's minds go wild. They think we've made all this amazing. They think we've made all this amazing settings and what have you. I think we've made this like some giant like Beowulf cluster with distributed load between all the nodes, maybe using some really cool modern tools like Kubernetes. I actually don't know how you're supposed to pronounce that, sorry. But that's not what we've done. Sorry to let everyone down. It's a bit more simple than that. So with the software, in fact, it is a bunch of independent nodes running all by themselves with custom Debian 10 images with the Linux kernel 5.7, with all their storage being handled by a dedicated storage node within the cluster, which delivers it to each of the functioning nodes over NFS, which admittedly is not fantastic for the task. We will be switching to iSCSI soon. And for your requests to make it to each of the nodes, it goes through an Nginx reverse proxy. We did this because it was a lot faster to bring up than a proper distributed cluster. Because by the time we actually had this thing up and running, we're about 2 weeks from where it had to go live because we were losing our previous hosting. And it's simple to add stuff to, because if you want to bring up another service, just bring up another node, set up the software on it, and route reverse proxy accordingly. The downside of that, well, things get a little messy here. Also, sorry if I got a little off track there a second. My other computer went offline, Can everyone still hear me and see my screen?
Yep. It's
Yeah,
working
we've got
fine.
you.
Right here.
Your non-Pine computer went offline.
Yeah,
right?
my non-Pine computer went offline. The big fancy power-sucking desktop went offline. But okay, we're still good here. I can keep going, though I won't be able to see the questions in the corner of my eye. So moving on to start of the show, trying to run Synapse on the cluster. Alternative title, The Trials and Tribulations of Running on 4 gigabytes of RAM. So for a year or two now, the Pine 64 chat network has been distributed between several platforms, Matrix, Discord, IRC, and Telegram. And of course, with Matrix in particular, with us bringing up our own hosting, people have been asking, when is there going to be an official Matrix home server for Pine 64? But really, we were kind of aware that Synapse could be rather resource intensive, so we really just didn't have the hardware to do it. But now we have 24 of these boards sitting in a data center with a big internet pipe. And after the initial deployments of all the websites, wiki, forum, and all that, only 6 of them are being used. So why not give it a try? We've got the hardware to do it. So doing all this by the book. So after I got all the initial stuff set up, time to try to set up Synapse by the book, install.markdown file with a sequence that probably anyone who's tried to use Synapse before is pretty well familiar with. Fight with the dependencies, install Synapse, make the configuration, start Synapse, make another config after you realize the .well-known file exists and you should have made the server name pine64.org instead of matrix.pine64.org. And when you change that afterwards, everything gets angry at you. Restart Synapse, realize that SQLite is awful at running anything in production. Install PostgreSQL, restart Synapse, and it works. Mostly. The victory was kind of short-lived there. A little bit of a tangent here. The Pine 64 community is quite large. A little bit of humble brag there, of course. If I'd gone through all that process with Synapse and this was just supposed to be a small personal server, the story could probably end there. It'd work happily ever after. But it's not a personal home server. As I said, the Pine 64 community is quite big, with several of the rooms having in excess of 400 users, and the PinePhone in particular being over 1,300, with people using many different home servers to connect to it. It turned out to be a bit too much for this single node to handle. When a few hours later, I found that Synapse had gotten out of memory killed. And this was the point I realized where Synapse, when you're trying to deal with big rooms and plenty of home servers to talk to, it really likes to eat up your RAM. I tried to tweak some settings to fix that, but nothing worked. After a few hours, it would just continuously run out of memory. This normally wouldn't happen on a normal system because swap space is the thing, right? That's what it's for, so you can use up all your RAM and not crash the system. But remember, each of these nodes is running its root file system off an NFS share, and putting swap space on an NFS share seems like an absolutely awful idea. We could also give the node local storage, just basically plug in a flash drive to it or an SD card or what have you. Maybe we technically could do that, but that's kind of a kludgy solution. So we'd rather not do that. So we'd look another way. Synapse does support splitting itself into workers on several machines. So we still have plenty of nodes to spare. Let's split it between 2 nodes. And go through another sequence of events. Read the workers documentation, spin up another node, write the worker scripts, get lazy for a month because I got busy with other stuff. Get a private message on Matrix about this certain event called Open Tech Will Save Us. Immediately start scrambling to try to get Synapse running in time for that event. crashed the second node hard enough that the other sysadmin had to go there in person to physically intervene and reboot the node, and finally get Synapse running again. Again, mostly. So at this point, Synapse was running, but Federation seemed to be a bit broken. It's talking to all the other home servers that I could see. I checked the Federation logs. It was talking to pretty much every home server just fine, except for matrix.org, which is a bit important because, after all, that's where most of the community is, where most community is, for better or for worse. Which means with the Pine64 home server, there is a lot of missing messages in the rooms. This is probably why the Matrix network needs more home servers, so that this sort of issue doesn't happen, but it's kind of the situation that we're in. Anyway, I started trying to troubleshoot that when out of memory again on the second node handling the Federation. At which point I was pretty much out of time because I was working on that up to late night last night before this event. I wanted to have it all working so I could proudly declare that the Synapse server was running and everyone could just start using it, but I guess that's just how life goes. If anyone knows what's going on there, I would really like to hear from you. People have told me that matrix.org is just massively overloaded, which I am aware of, but the issues seem to be a little deeper than that because I've had it up for like a day and there's still kind of the same issues, so it doesn't seem to just be straightening itself out. Did I just disconnect?
No, the other Matthew did. You just happen to have the same name.
Oh, well, I heard the disconnect noise. Okay, so anyway, if anyone wants to give the server a try, I do still have Synapse running. Last I checked like an hour ago. It is running with the questionable Federation. It's matrix.pine64.org. I'm pretty sure registration is open, so if you want to join it, go right ahead. But for this presentation, that's kind of all I've got.
That was plenty. Thank you.
So
hope it was good.
While I try to figure out why my other computer screens all went out, I can, well, actually, let me in the screen share and get my camera back up.
Sure, I can relay some of these questions to you, Matthew. Thank you very much. And I also like the fact that we basically encourage you to get your home server up and running by making you do a presentation.
Yeah.
Shame we didn't get it perfect for the day, but we were very close. I think you were very close. So there's a few questions. There's quite a few actually. So I'm going to ask Matthew's questions first. So the question is how the hardware of the PinePhone and the power consumption relates to something like the Librem 5, which is probably the other big name in the space. I don't know if it's an unfair question, just because obviously you're so integrated with it, but see what you can do.
Yeah, like it's definitely a question that I have seen a lot. Like with the power consumption in general, they're probably talking about how the all-winner A64 SoC it uses isn't the most power efficient thing in the world because it's been around since like 2014 or something. But at this point, thanks to, again, a lot of community work, the power consumption is pretty well under control, thanks to especially one piece of software that's called Crust, which is basically power management firmware that runs on the embedded controller on the PinePhone. So it can actually have proper power down states. And I believe at this point, the figure is the PinePhone can run about 100 hours straight if you don't have the cellular modem running. And if you do have it running, about a full day, I think, is what you can expect.
Wow. So, I mean, competitive with a mainstream commercial offering.
Yeah, it's competitive with a modern Android or iPhone or what have you. That had been one of the main issues that people have been bringing up whenever over the last several months, but that's pretty much under control now.
Yeah.
I can't speak for how the Librem 5 is in that department because I'm not as integrated in their community.
No worries.
And yeah.
So there's quite a few questions here. So what I want to know is about the cluster. Why? What is it? Is it just because we can, or like a marketing deal, or like it's a lot of work for you? Why are you doing it?
Well, I think it kind of started as a wait, we can do this.
Mm-hmm.
It's like half of it is a hardware company. And again, that's pretty much going to be a practice what you preach, or like I mentioned in the presentation, dog fooding. Hardware company, let's run our infrastructure on the hardware we make.
Yep.
As for the difficulty of all this, I'm not going to lie, it has been pretty difficult at points, especially with some of the issues coming up, like with using NFS shares for your root file system. Don't do that, by the way.
Yeah.
We've been having issues with that crashing.
Okay. All right. So actually, a question this just came in. I don't even know if this is your department. Can you switch from Matter Bridge to the native Matrix bridges? Just because the UI is so much nicer.
I was waiting for that question to come up. So
sorry.
So the reasons that so far I've been using Matter Bridge is that in general it just works. It's this one piece of software that you just have to run once, and it works well, and will bridge Discord, Matrix, IRC, and Telegram all together with not all that much config.
Mm-hmm.
While maybe I'll say something a bit wrong here, because obviously I'm talking to people who are probably way more educated on this than I am, but to my understanding, a lot of the native Matrix bridges are pretty much just Matrix to one other protocol. So it'd be a lot more software config. And
you would be running multiple bridges. Yeah. That's true. I mean, I don't know if obviously I would say it was worth it for the UX improvement, but yeah.
For the UI, it could definitely be a benefit.
So this is not. Oh, sorry. Get some lag.
But the just works feature of Matter Bridge so far has been hard to beat, along with the fact that some of the native bridges we can't really use in our use case until we get our home server properly up and running, which has kind of been the main holdup.
Fair enough.
So what's that question?
So this isn't really a question so much as a comment from M52Go. With the sheer amount of activity in products and community engagement I've seen with Pine 64, I would have never guessed everyone was contracted or volunteering, which is amazing. And I quite agree. It's incredible. How do you think they managed to hold the community together and keep everything running? And it really feels like a proper commercial company.
Well, do I have a good answer for that? I'll say it's kind of two factors. First of all, I think it's the founder of the business side of Pine 64, TL, who is, when you talk to him, an amazing guy who really cares about people, and from the start was trying to get a strong community going around all this. And also, admittedly, it's kind of sheer luck, like the right people in the community finding us at the right time.
Okay, fair enough. I mean, that's it's just having the right people. That's the core.
It's right people.
Yeah, it's the core of everything. So we've got one more question. Is the ISCIC change related to the store being down?
Sorry, say that again.
Is this question's from M4RTH. Is the ISCIC change related to the store being down? I don't know if that was a joke.
No, it's not. Those are separate. In fact, at this point, the store is pretty much the one part of Pine 64 online stuff that isn't running on the cluster. It's still running on an Amazon AWS instance.
Right. Cool.
Sooner or later, we're probably going to move it, but since we've been having so many product launches, that keeps getting delayed.
It's crazy how much is going on the website. There's just so much going on. I mean, I remember when the first time I saw the Pine phone at FOSDEM this year, I was like, wow. This device is phenomenal, like really, really impressive. All right, Matthew, thank you very much. Is there anything else you wanted to say?
Don't really have much else to say. Like, I can't really say much on this matter, but from what I have been talking, from what I've heard on the inside, we have a lot of interesting stuff on the horizon coming up that
I bet you do.
Going to want to see.
Yeah. Cool. All right. Well, we'll definitely looking out for that. I think everybody's going to be paying a lot of attention. Thank you again.
Happy to be here.
Oh, what's the pine sill?
Oh, the pine sill. So that is going to be, well, like, I'm sure most people are probably familiar with like those like battery powered soldering irons, like the TS100 and so on. It's kind of our version of that, except the onboard processor on it is a RISC-V processor.
But ultimately, it's a soldering iron?
It's a soldering iron with a RISC-V. I don't know if it's a proper micro, if it's a computer or more on the microcontroller side of things. But
what's the benefit?
Soldering iron.
Right. Okay. But why? Soldering irons only have one variable of heat, don't they?
Like cheap ones do, but like with that TS100 I mentioned, like has a little screen on it, and ours is going to, and you can control the temperature like by degrees Celsius and all that.
Cool. I see.
I'm upset that you hadn't like a reasonable answer to that question. I wanted it just to be why not mad scientist rather than rational like.
Yeah, my incredulity.
I'm not really in like the hardware development side of things. Like I'm pretty well familiar with that sort of stuff, but I'm not part of it at Pine 64, so I can't really answer the why. So I'll say why not.
Oh, it could be voice controlled. Up 1 degree, up 2 degrees.
I don't know if it has a microphone built into it, but it's
V2.
Like the schematics are going to be open like all the other Pine 64 products. So if you want to add a microphone. Make a voice-controlled soldering iron.
I think that somebody will now. I hope to see that soon.
I want to see it.
All right, Matthew, thanks again. We've overrun a little. So I want to say thank you very much. I know that everybody in the chat was enjoying that. So we've got one final speaker, but before we get to him, I want to say hello to, I'm going to mispronounce this, I'm sure, Asbjorn Oling. And his pals in Denmark, who I think are watching at a some sort of hacker conference / meetup. So hello, Danes. So we have one final speaker, which is Nad. Nad is my colleague at Element. We work together on various things, but he is sort of our main designer. And this year, his magnum opus has been to work on the new branding for Element, the product, Element, the company. And yeah, just the amount of work that went into this was huge. And I think it's important to share that. And I want to let him present now. So, hey, Nad.
Hello. Yeah, thanks for that very generous introduction. And I'll also just sort of build on that a little bit. I feel like I'm giving an Oscars acceptance speech at this point, but it was definitely a sort of a team effort. And so shout out to everyone else on the design team, where we scaled it this year there as well. So we had a couple of awesome designers join in the name of Nick and Rock, and also just everyone behind the company that sort of piled behind a pretty big project for us at least. So yeah. We haven't really discussed the format for this. Ben and I have a little bit, but Matthew, feel free to add at any point and sort of keep me honest. I think the last time we did one of these, we discussed the sort of good cop, bad cop kind of.
I'm not expecting to do anything. I'm just here to watch and be an audience and sweat profusely at you. So have fun then.
Yeah, great. All right, so I've prepared a few slides. They're mostly for me, to be honest. They're just so that I don't forget to say things. So I'll run through these over. I don't know, we'll see how long it takes, somewhere in the region of about 10, 15 minutes. And then I think it could be more fun to then switch to more of a Q&A where we can see what kind of questions people are asking and also just sort of field things from there. So Element, Open Tech Will Save Us, number 5, here we go. So a little bit about me, after that very generous introduction from Ben. So I'm Nad, I work on design and product on the Element core team. Product's one of those weird things, I think, where if you ask 50 different people or 50 different companies what that means, you'll probably get 50 different answers. But I think For today, and for what we're talking about today, I think it's probably best just to think about it as how it works and why it works. Or I think often why it doesn't work is often the case with once you get to kind of products of the kind of scale that we have at the moment. And then otherwise, you can generally find me on Matrix in the Element Design Room. Is probably where the easiest place to find me, or just feel free to DM me if you want to reach out. The Matrix ID is over there, as well as just sprinkled throughout various design rooms across the Matrix ecosystem. But that's me at a glance. So hello, everyone. Hello to the Danes as well. Very excited that you're with us. And so what I want to talk about is just where I want to start is where we were, say, a year ago, thereabouts. And I'm going to presume some knowledge on all of this, but I will sort of take it from the top. But we've got, on the core team, we're kind of involved with various different projects, various different initiatives. We've got Matrix, which is the core protocol, which is open source. Prior to rebranding to Element, we had an app called Riot, which was the flagship reference implementation for Matrix, and the flagship client and the most mature client in the Matrix ecosystem. Separately, we created a SaaS platform called Modular, where once you had your client, you could take that and then provision a server with very little technical knowledge to get all the benefits of having your own server without having to run your own server. And then separately to that, we had a legal vehicle, which we still do, called New Vector, which was kind of set up to feel sort of enterprise and consulting and just be a sort of vehicle for us to take people's money and pay ourselves and do the legal things we need to do to be able to exist. And that's where we were. And this kind of made sense when we were growing an ecosystem. And this kind of made sense when we were small. And the problem is that things change pretty much. And so one thing I do want to just really, really overstate, I'm sure that Matthew, you've overstated this continually. In fact, I know you have because I've heard you.
I was about to jump on in the heckle to make sure that you did overstate it.
Great, awesome. Yeah, I just really want to overstate that Matrix as a protocol and as a brand and as a name is Matrix, and that's that. And that will always be true, the same way that email will always be email, no matter what services are being built on top of it. And that we've set things up, we've set up protections. In case we ever go evil, there's a non-profit that guards that, et cetera, et cetera. And so that's where we are with Matrix in relation to everything else we're talking about today.
Yeah, if I can just sort of double down on that. I mean, originally, of course, we created Matrix and then subsequently created New Vector as a company to hire people to work on Matrix. But Matrix itself is not part of the New Vector company, which is now Element, or the commercial side of things. It is completely controlled by the non-profit foundation. And it's been a really tricky thing to split the two apart. It's really interesting hearing other Matthew talking about the Pine 64 structure between the Pine store and the project. I mean, we have it as a slightly different split on Matrix in that you have a formal foundation for the non-profit stuff in the form of Matrix, and it very deliberately doesn't have any control or even the same name as the commercial side, who are finding a way to try to hire people to work on it. And we do have full-time employees rather than just contractors on the commercial side of things. So in my mind, it's we should probably not even have Matrix on the same slide as Modular and Riot and New Vector, because it's just a different organization. It just happens to have been founded by the same people who also founded New Vector. Sorry, Nat. Back to you.
Oh, good. Yeah, so just from there, really, so just building everything Matthew was saying there, despite the fact that they are completely separate projects, with us being the same people, sort of a repeated pain that we found was that there was just a high barrier to entry to understand that. You know, you needed to have exactly what Matthew said just then in order for that to make sense. And so we'd created this kind of artificial barrier to actually being able to join the ecosystem, and that's kind of what we were aiming to simplify at the core of all of this, basically. And so we went from having those kind of three principal sort of commercial initiatives down to one, where actually they're not all commercial either. There's the Element apps, which are open source, and I think we open source. I'd love to get the numbers on it, but shooting from the hip, I'd say 90-something% of the code that we write thereabouts.
96. I did the maths the other day.
Oh, great. Yeah, so we simplified everything down to the apps themselves, a SaaS platform, which we call Element Matrix Services, or EMS for short, where you can grab your servers, and then a bunch of other sort of enterprise and consulting services, as well as all the legal stuff that we sort of just need as table stakes in order to exist in the first place. So that's where we are today. And so I mentioned that the goal there was simplifying it, and I think there's another really interesting way to look at this. I know, Matthew, we've looked at this before. I don't know, Ben, if we have, but this is the technology adoption curve, where you have this kind of bell curve of technology adoption, without wanting to rephrase it. And essentially, what you do earlier in this curve doesn't necessarily always work when you're progressing through this curve. And so things change, and that's absolutely okay. And that's just, I think that's just the ebb and flow of technology itself. And so I think what we've been finding is that as we've been progressing through this curve, and as Matrix and our apps have been increasing in adoption, we've needed to respond to things changing. And that will also always be true as well. So, things may change in the future, strategies may change, and that's totally fine, as long as we're aware of it and as long as we're prepared. So I've kind of just gone through this a little bit. So yeah, depending on the maturity of what we're doing and how accepted it is, things change. We wanted to reduce the friction to actually join the ecosystem. We wanted to reduce confusion, and we just wanted to make it as easy as possible to be able to get involved, and ultimately also as an end user to not have to learn 5 things to get value out of one thing. So we were really just looking to reduce barriers to entry all around. And some of the sort of goals, I guess, on the rebrand were that we have a huge variety of personas in terms of, we have people that use our apps for personal messaging to keep in touch with their friends and family, all the way through to entire governments using it to run governments. And so there's a huge challenge there in terms of how we could do that and how we could build something that could serve both of those at the same time. And same again, I mean, the use cases speak exactly the same point over there. But another sort of major goal of ours is that we were really trying to solve things for the long term. So we weren't sort of thinking about things with like, how would this work over the next few months, the next couple of years? It was really more like years and decades. And there's some background work that's gone into that around sort of trademark lawyers and stuff like that, just to ensure that we can defend our IP essentially, and that we can protect it. And ultimately, we're doing all of that in order to ensure we can have a good experience for the end user, pretty much. And so there's a lot of kind of background work going in there to ensure that that's the case. And just really briefly, I don't want to sort of get stuck in the visual weeds of it all, and we can sort of QA on more stuff soon, but here's the new brand that we worked on. We ended up using a logo type from a family called Aina, which was made by a design school in Catalonia, I believe, which is very beautiful and very great. And then we're using a really awesome open source font called Inter, which is made by a Swedish guy called Rasmus, who used to be at Spotify, who's now at Figma, who's created an incredibly flexible and legible display font, which we're using almost exclusively, actually exclusively throughout the app now. And we had a lot of challenges doing this. We chose to do this internally, and we did that very deliberately. And branding is this weird thing where it's never sort of done. I think there's actually more of a corollary to sort of the fashion industry and the tech industry than we admit to ourselves sometimes, in that it's never just finished and you never go, tick, I've designed the t-shirt, I've designed the dress, I'll move on, like that work is done. It's ever evolving, technology evolves, and then that enables new solutions, which then means that people have different expectations, and then things change and applications change and use of things change. And that's also true of the branding, and it's true of what we're doing. And also no one's done what we're doing before. So we're kind of walking this bridge whilst we're building it underneath our feet and figuring it all out at the same time. And so there was a lot of internal work really around trying to denaturalize all of that and sort of figure out something that would serve us for the long term. And also just one thing I haven't talked about yet is just the idea of sort of tastemaking and also the idea of ego. For us, like, I think everyone that works on the core team is incredibly passionate about the project. And so even though it is just the logo mark, it's what we wrap ourselves up in. And we sort of say to the world, like, this is us. And so, it's something we hold very dearly, and we sort of, we treat that with a great deal amount of respect. And so that was one of the sort of major drivers internally as we worked on this as well. I've mentioned most of this, that we worked on it internally. One thing that we did do actually is that we were very deliberate about timing the release of this with some impactful product changes. So we've been working on RiotX for, I can't even remember, over a year, like a year and a half, thereabouts. And
it's about 40 months, I think.
Okay, cool. Yes, we've been working on RiotX for that long, and we were just about nearing being able to take it out of the beta channel on the Play Store and F-Droid. And we wanted to time that along with coming out with a new brand. Separately, we had some really interesting kind of new flagship features on the web and desktop clients, and things like a completely redesigned room list, where we were really trying to challenge room navigation, which is one of those really fascinating problems where on the surface level from 1,000 miles away, you just think that's a solved problem because how many chat apps exist in the world. But then, you talk to Matrix users and there's such a mix of personas and use cases, and trying to satisfy all of that at the same time is a really interesting challenge. And so we had a new did a load of work on the room list and some other features that went in there as well. One thing that I did want to highlight as well is that we also talked a lot internally about anticipated responses. So if you're doing anything right on the internet, you're going to get haters, I think, and that's just there should be a law on that, like haters law. I'm sure it exists. And one of the really interesting things that we sort of rationalized a lot internally was using a dictionary word. And so we went through some very eccentric processes, which I think is what you have to do for some of this to arrive at the word or the name element. And honestly, on most teams, I think I would have been super apprehensive about arriving at a dictionary word that already exists. But thankfully, we're also the core team on Matrix. And so we've already done this before, and we have some experience at it, and we think we knew how to kind of navigate that. And so, yeah, that was one of our kind of, not core concerns, but one of our core anticipations when we launched. And so far, so good. And yeah, we'll continue to ride this out and see where it takes us. And I've already gone through this, I believe. Yeah, I did do. Yeah, so we talked a little bit about RiotX. We talked a little bit about the room list. One thing I did want to sort of flag as well, especially for the designers in the community, we moved away from using an open source icon pack called Feather, which we were using before, which was a line icon set, and we actually developed and designed one in-house instead for two reasons. We did a bunch of research on accessibility and figured out that solid fill icons are way better for accessibility for a host of different reasons, which makes sense as soon as you look at them. And so we wanted to satisfy that. And then we also couldn't find anything that met all of our needs. And so we shipped to this early this year, and then later on, we'll figure out what more we can do with that. So that might be in the form of an open source UI icon set that other people can adopt for their projects or something like that. But we'll see. We'll see what happens there. Yeah, and then the same way that I talked about the sort of naming and the logo mark itself, kind of laying the foundations and saving us for the long term. A lot of the UI changes in the core product were centered around that as well. So we used it as an exercise to give everything a bit of a visual refresh, where the web probably changed the most dramatically. And that was a really good exercise to lay the foundation for the future, pretty much. And this is what it looks like. I won't talk too much more about how it looks, other than we stumbled across some really interesting things, I think. Like one of them, which I will call out, is it's really subtle to tell from these screenshots, but actually the app is tinted based on your profile picture. And one of the inspirations behind that was that we wanted the visual design to support the goals of the entire project as best that they could. And so we really loved the idea of the app molding to you. And even if your eye doesn't register it, I think somewhere deep in your psyche, something does. And there's something really nice about the app representing you and representing that sovereignty of that data, and reinforcing that the conversations do belong to you. And there's more that we'll do with this in future, and especially as we look at developing more features like improving communities and some room-specific features around managing rooms and stuff. We'll sort of look at sort of the ego of the user versus the ego of a room versus the ego of a community, and the kind of things that we can do there, which are really exciting. But I don't want to, it's not for me to say whether or not our work was good, so just go and try it out yourself. Element.io, and download the apps, check out the web app as well if you're not already using them. And then really briefly, before we sort of go to conversation, I just wanted to talk a little bit about what's next. The headline, I'd say, is closing the gap with closed source software. And more specifically from there, or to dive into that further, we could sort of look at the kinds of things we have on the horizon and that we're working on at the moment are just huge usability pushes, especially around the first-time user experience. So we want to make your first 24 hours with Element and with Matrix as successful as possible. I talked a little bit about accessibility. We've got some stuff in the pipeline to have improved WCAG AA 2.0, I believe, is the taxonomy themes and stuff like that to help people out who maybe need that. And again, as we do new feature development, we've invested quite a lot into ensuring that we have really great screen reader support and stuff like that, and that's definitely a priority moving forward. Some of the things which I think are really interesting if you're an Element user is we want to embrace having more respect, I think is a really interesting way to look at it for cross-platform users. So if I do use Element on Android and then I come to iOS or I come to the web, I should be able to reach for those, and they should just make sense and I shouldn't have to think. And that should be intuitive. So there'll be a lot of work happening there, as well as really interesting flagship features, upcoming stuff on communities, message threading, and literally we have a really interesting product roadmap, the length of my arm times 10, which is great. And also as a very small note, when we can, I really want to try and see what we can do in terms of progressing the notion of open source design itself, because I actually don't think anyone in the entire industry has done a really great job of this yet. And so I think it'll be good to push the envelope a little bit there. And that's me, I think, for slides.
Very good, thank you.
Yeah,
having seen it before and seen some of the development with it, I just really like that brand. I think it's really cool. I mean, I have a slight bias, but not too much. I think I'm trying to be as objective as I can, and I like it a lot. All right, one of the topics that came up for me was a bunch of stuff came out at the same time this year. So the whole rebrand, and the logo, and the essentially Riot X becoming Riot Android and the associated becoming Element Android and the associated client launches along with that. Isn't that two separate projects? Why was that done as a single release, and how does that affect the process?
I think there's I think the sort of typical way to do it would be maybe to perhaps outsource some of the branding work. Obviously, if you're a good technology company, chances are you're building your technology in-house, because that's just the way that you get good results. But for us, I think the way that we looked at it was that really we had two different jobs that we were doing at the same time. One of them was solving problems, and that was very user-driven and very technology-driven and very product-driven. And so we just wanted to do a really good job of solving problems and making sure that people could achieve their goals. And the other job that we were doing was, to be blunt, was just putting rectangles on screens. And like in UI design, or if you're designing for screen rather than print, just everything's a rectangle. And whether you're making a logo mark and then that's going into the logo and some web navigation, or you're making a logo mark and that's going into an app icon set, or you're using the same accent colors in the branding throughout the app or whatever, you're just making good decisions on how to use those artifacts across different mediums. And thankfully, we have all of the domain knowledge we need in-house to be able to work with really great respect across those mediums. And we were able to, tackle the branding as well as the core product, as well as a lot of the technology problems along the way, all as one. And I think also we struck across a lot of solutions that we just wouldn't have had we not done it that way as well, which is, I think, for me, really exciting, and that's what gets me up in the morning.
Very well. So this is a minutia question, but I think I want to throw it out there. Why is everybody so obsessed with Inter? Like, it's pretty good. Is it that much better than Helvetica? So a pal of mine, Doug, looked at the element.io, and the first thing he said was, "Oh, Inter, great."
It's without getting stuck in the typographic weeds, fonts. Well, let's go back a little bit.
Oh, God.
We invented books, and then we needed to print books. We did a bunch of things that worked really great for that. Then we invented computers, Then we invented a GUI. Then we had bitmap graphics, etc., etc. Along that way, everything stemmed from books, essentially, and print. And type design also did as well. And in the last sort of, I'd say, 5, 6, 7, 8 years, I think sort of roughly when, I think on the one hand, Google came out with Roboto and then Apple came out with San Francisco, there was a huge push to basically say, hang on a second, let's just reset and let's just accept that we work on displays now. We don't need to worry about books. And so let's design display typefaces for that problem. And I think the thing that enabled that was actually high density displays, which was probably like iPhone 4 era Retina, where suddenly you couldn't distinguish individual pixels, and that kind of made that possible. And on the typographic level, the real difference, more or less, with really broad strokes, is a larger X height. So if you look at the size of an X against the size of kind of a full height capital letter, the height on a good display typeface is much larger. And it's this subconscious thing where it just makes your eye love it to read it. It's just 10 times more legible, 10 times more readable. And so the bowls on an O also match that X height, etc. And it just means it's way more legible at smaller sizes. And your eye and brain just find it 10 times less fatiguing to read, basically. So that's kind of the typographic argument. The other argument is that font licensing is nuts, like absolutely nuts. You pay per license, per installation, per deployment or whatever, and this literally racks up to the tens to hundreds of millions, depending on who you are and how you're using it. And also it's really, really hard, and that's partly why it's so expensive. And so Inter is essentially an open source version of all of that. So you get literally, building on decades of type knowledge in an amazing open source font that solves all those problems in a way that almost no other typeface does, thereabouts.
Cool.
What I'd say on that.
So it's pretty and it's free. Is that the?
More or less, yeah. It looks good and it's free.
No, I like it a lot. I just I know that a lot of people are really passionate about it, and I wanted to get a bit more info.
Don't get typography people started on typography. You'll regret it.
I don't yet, but I will. All right, let's talk about the process more. Why was it so important to have it internal? This was developed entirely in private by the core team. Why not use an agency? It's quite common to use a branding agency for jobs like this.
I think because the details really matter, and the details are often driven by technology. And the fact is that nobody has built the technology that we're building before. And so to ask, it would have just been a really tough ask, to be honest, from someone external in order to actually be able to sort of onboard and empathize with all of our goals, and also to work in a way where, the core product and the brand can support each other. You kind of need to understand the core product to be able to do that. And so for sure, there's inefficiencies in doing it the way that we did, but we're happy with where we got to. And like I said, like if I come back to the fashion analogy, we think we've arrived somewhere that's going to serve us really great for the long term. And even if we do iterate on it slightly in the long term, that's also okay. Like look at companies like Airbnb or Facebook, who have rebranded the entire company at Facebook scale. And again, it's because things change all the time. And, there's, partly the reason why they did that was I think they were responding to a political problem, and that's not a problem they had when they chose their last logo. And so, I think if you take the right care, I think it's, and I think actually it's great if you're improving, and as long as you're doing it in a way that doesn't alienate people along the way as well. I don't think it's a thing to be feared.
Yeah, I see that. I mean, it's quite a commitment though, to make a change. Yeah, it's something that you talked about wanting to think in terms of years and decades, and to be able to vary slightly within that is a skill, I guess.
Yeah, I think also when I say that, I think I'm probably speaking to my inner child a little bit as well. Like I genuinely remember the first time that I saw the Firefox logo when I was a kid, and so
wow.
There's an element of also, I hear myself say the word element every time I say the word element now. But I think there's just an element of really just wanting to make the right choices and just have things stand on their own feet, like in the future moving forward, basically.
Yeah, for sure.
Matthew, you are muted.
Yeah, he's itching to say something.
That's why I can't interrupt. So I was wondering if we should talk a bit about the history of the rebrand and whether folks who are interested in Riot and Element might be interested in where the name came from and how it came about. Because it's a bit of a weird one. It's kind of like Dendrite in the, I think it was in the middle of 2018 that we started seriously considering whether to rename Riot due to the problems that we were having trademarking Riot as an app, as well as concerns about it being too violent, even though it's meant to be like, that guy's a riot at the party. It's meant to be kind of fun rather than Molotov cocktails and breaking people's noses. So we were basically, I think just after you joined that, actually, towards the end of 2018.
Day one conversations more or less was like, we have this thing.
Yeah. Okay. So easy thing to go throw at the poor guys with us to come on board as the first proper professional designer to work on matrixy stuff for Element or Riot or New Vector or whatever we were, and said, hey, we're thinking about renaming the app. Shall we do a branding exercise internally to try to come up with a name? So now, do you think it would be an awful idea if I screen shared our notes from 2018 with the comedy reveal that we came up with the name Element in November 2018? I don't know if we want. Do we want to leak any of the other names that we had flying around? We don't want people to be stealing the word badger for their apps, for instance. I think this is a terrible idea, but Ben, I'm going to go off piece just for a change and try to screen share, and perhaps people will find it vaguely interesting, just as a little bit of random matrix history, if nothing else. So let me try.
This is when we were like sort of benchmarking and tastemaking with stock icons and stuff, right? And
yeah, precisely.
Trying to get an idea of seeing things in lights, more or less, to see where we could or couldn't go.
So this is literally a document on Google Docs called Renaming Riot. It's not public, unfortunately. And we sat down and wrote down our requirements. And this would have been some point before November 2018. So it was like a month or two. And we said, hey, wouldn't it be nice if it could verb? I'm going to Google you or whatever, which we failed with Element. Something that people can spell, hopefully something that we won. It's got to be appealing and understandable to a wider audience. That's obviously very subjective, but hopefully it's appealing. And whilst it's understandable, people aren't going to ask you to spell it out. Needs to convey the idea of connecting people together, communication, openness. I'd say that there's an element, so to speak, in which we have gone and at least had the idea of sovereignty and agency, and an element being the smallest part of a whole that represents you and your ability to interact with other elements, much as we do in the real world. Then this rather obscure idea of being svelte, sexy, suit, elegant, clean, fashionable, don't be boring and blue and bureaucratic and corp. There's a definite risk that Element ends up being too corp. Hopefully we've sort of got the right balance there. Hopefully we're more on the svelte and sexy suit end of things, so particularly with the visuals on the app. Could be something a bit provocative. I'm trying to steal the word element is probably pretty provocative. Visual friendly, obviously lots of visual ideas. Could be a portmanteau, something Googleable. Anti-goals, not too corp, not too black hat or cryptographic or cryptocurrency, not too cute, not too aggressive, not too political, and we don't want it to begin with S. And you can say how old this is and that we're seriously considering Stride and Skype as competing brands at that point. And came up with all sorts of random ideas to get inspiration from openness, light, transference, liberation. In fact, there's one point where it's very nearly called Liberate. In fact, I still own liberate.im as a name. Gaia, resonance, energy, flux, crystallization, electromagnetism, physics, and we were basically just brainstorming for a couple of hours. Phlogiston, ether, alchemy, have we actually hit it yet? I don't think we have at this point. And it's kind of rolling around the place. And apparently Annalisa Flanagan has the loudest voice. I have no idea what the context for that was. I think that Tom, who works, used to be the delivery manager for Riot, went off and built this massive mind map of what was going on in his head in terms of product name in the middle, and it just explodes off to different words. And it just carried on, comparing it with other apps, and then we started to shortlist it. And we were playing with things like Air or Astral, Coral, Lux, Raven, or Spoke. And often these aren't serious ideas. It's more just trying to get an idea. And in the room, it was myself and Amandine and Nad and Dave, who we stole fairly much at random from the Riot web team to give input. And for whatever reason, everybody was interested in Minim. I'm kind of glad we didn't call it Minim, because that's a really strange name. I got excited about Astral and Astral projection and auras and things. And then Nad was taking, basically building mood boards of existing artwork typically. I don't think anything is ever original here. You're just basically pulling stuff that sprang to mind to try to flesh it out and see that if we called this app Air, what sort of ideas would there be? So there's the O2 logo, there's this fancy feather idea, there's the hot air balloon. And then we were basically taking our feedback, Amandine saying it's a strong change from Riot, but it looks pretty as a written word. Blah, 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 blah.
I'm slightly terrified because I remember these conversations got really weird.
Yeah, they did.
I'm worried about what's in these documents.
Yeah, perhaps I'll skip over. Let's look at the pretty bits. I think Astral is still a cool name. I'm sure that a lot of these have already been used or trademarked. You had a Coral as an idea, like the distributed system. There was Lux for light. There's Raven, and noticing the sort of brave sort of aesthetics for that, and good old Firefox logo in there, as well as Thunderbirds, etc. Then there was Spoke, and then we kind of went back to it again. And apparently on the 5th of December 2018, we went and reviewed them, and we came up with a new shortlist, which had Element on it. And apparently that came from me, which I don't remember at all. But I was pointing out that Elemental might be available and all this sort of thing. And then it just goes on and on and on and on and on and on. And we went into Badger relatively seriously, should we call it Badger? And then finally, you had some of the ideas that Nant was riffing on for Element, whether it's literally the elements, or is it something like Atom, or is it more chemical? But in the end, we decided to shelve the entire project, because we knew that we were going to totally redesign Riot at FOSDEM in 2019, and were worried, frankly, that it was a very radical change to the UI, getting rid of all the old green stuff that we had before, and also had it was basically a risky maneuver, and we didn't want to risk screwing it up if we also changed the name at the same time. Because if we completely blew the name, then people are going to associate the redesign with it, and we can end up accidentally it all falling apart. So having done all of this research and come up with a bunch of possible ideas, we completely shelved it until we were happy enough that we were out of beta, Matrix was out of beta, and we had all the convergence of other things that now just explained that we could do as an excuse to rebrand it. So Nad says it's hard to imagine people disliking Element.
I was just going to say, I think I'd sort of forgotten that we made that decision, but I think that speaks to what I was saying before about change being okay if you can take the right care with it. So we were just genuinely worried about changing too much of the app and the name at the same time, and then people, transitioning and not understanding that it was the same app that had transitioned. So this is definitely something, and we did literally a year and a half of sleeping on this in order to have confidence in the right decision. So it's definitely something that we were interested in getting right.
Oh, I'm kind of glad that everybody also likes it at that point. So it's slick, crisp, cool, scientific, precise. Science-based mood is a bit too dry, blah, blah, blah. So yeah, there you go. That's where the name Element came from. And we did then subsequently come up with a gazillion other possible names before basically going back to this and saying, sod it, it's probably the best one we've got. So there you go. What were we meant to be talking about?
It feels like the road not taken. All the things that could have been.
Well, Badger.
Badger's one of many roads.
I think we'll get sued by the EFF and Privacy Badger.
Cool. Oh, the other comment people had in the chat was, you're using Google Sheets? It works.
It does work. We also have our Etherpad, but yeah, Google Drive, unfortunately, has still got the best collaborative editing. And the second that something more open comes out there, which doesn't involve rendering on a server and chucking pings of your UI to your browser like LibreOffice does, then we will move over to it.
Cool. We talked a lot. thank you. Thank you, Nad. Thanks for Matthew for jumping in and talking about some of the history of that. I think we should wrap up and say thank you to everybody involved today. Thank you to Jonathan Berry. Jonathan had to step off because he is, it's like morning where he lives, which is California. So he is going back to work, or California time. Thank you to Matthew Petrie, who is actually volunteering for Pine64, but is doing some really, really cool work, doing some really fascinating stuff. And thank you to Nad Christie from Element. And thank you for talking through the Element branding redesign. So, good night. Open Tech will save us 5. Bye.
Cheers, bye.
Bye.